So, as Dr. Eckel said, our project is on using machine learning to diagnose brain disorders. And it's by me, Kunal from American High School.
Me, Sophia home from Columbia High School.
Me, Amish from Vista, Lago High School. Okay, so let's start with the background. All doctors utilize a multitude of tools and machines when assessing a patient's illness or symptoms. And processes centered around brain activity, many physicians utilize EEG signals, which is a test that measures activity in the brain. Understanding and analyzing these EEG signals allow for doctors to classify different harmful brain activities like seizures and stroke. So how do they work? EEGs work by measuring the brain's electrical activity with electrodes placed along the scalp. These electrodes measure electrical charges that your brain cells generate and prints that out as pages of data. In this diagram, you can see where the different nodes of EEG are placed on the head, where one's nose would be at the nasion and one's ears would be at A1 and A2.
Hold on 1 second. So on the previous slide, he's showing you this exact places, the exact sampling sensors that are placed on the brain where our data actually comes from in all these regions. Go ahead.
Yeah. So EEGs taken of those who have a disordered brain at the time of reading will have different readings than those who have a standard brain. You can see that an EEG of a normal brain has much more standard and smooth lines of voltage, and the EEG of a disordered brain has much more erratic and sharper lines of voltage. Doctors can use EEG readings to determine if a patient's brain is healthy and diagnose them with disorders or diagnose them so they can get proper treatment.
Okay, so like Amish was saying about the treatments that doctors can give, many of these EEGs diagnose conditions like Alzheimer's disease, epilepsy, brain tumors, hemorrhages, and things like that. And EEGs are commonly used by anesthesiologists so that they can determine the correct amount of anesthesia to provide to a patient in surgeries and things like that. So what is our project? So the entire process of setting up, taking scans, analyzing, and classifying as a whole takes a lot of valuable time away from many doctors and physicians. So our project is to automate this process by creating a large language model or an LLM. So this is basically a type of AI program that can recognize different codes and texts and compute them into different tasks. For example, it can look at the EEG values from our data set and then further diagnose a patient with a certain brain disorder. So how is our project useful? So by creating this model, we are going to be greatly decreasing the risk of misdiagnoses that we currently see in the medical field that can come from things like inexperience or other like minor mistakes. And it would also save doctors a lot of valuable time and energy that they could be using for other tasks. And this model will also allow patients to get diagnosed faster and further receiving the proper aid and help that they need faster, which can be very useful in emergency situations like seizures, which occur very quickly.
So what have we built so far? We started our project recently, but so far we have been able to use a Jupyter Labs notebook coded with Python to read several gigabytes of training data on EEGs that we've obtained. We created a training set of data that will feed to a machine learning model, which will hopefully, again, be able to, in the future, predict brain conditions based on new EEG values. We've also coded a program that displays the EEG data in a graphical plot to make it easier to visualize. So how does our data set work? Our data set has over 10,000 EEG readings that are recorded from thousands of different patients. The EEG ID, which you can see on screen in the first table, represents which EEG the entry takes the data from. And there are several entries from one EEG. Each entry from one EEG, which is represented by the EEG sub-ID, starts at a different time in the reading, which is shown by the EEG label offset seconds. The spectrogram ID works in the same way as the EEG, where there are several readings taken from one spectrogram, and they all start at different points of time in the reading. The label ID is a unique ID for every entry, and the patient ID represents which patient the EEG reading is from, because sometimes several EEGs are taken from one patient. Each of the EEG readings also has a consensus of several experts on which disorder or lack of disorder the patient whose brain was read in the EEG had. Each of these entries also has a corresponding set of voltage values that make up the actual EEG over the amount of time the reading takes place, which is shown in the second table. Each of the values from the second table, like FP1, F3, C3, P3, and so on, represent the voltage values from each of the nodes at a certain point in time in the reading. We can have our machine learning model analyze these voltage values or analyze spectrograms of them alongside the diagnosed conditions that the patient had, and therefore predict future conditions if they have similar readings. Are there any questions on our presentation?